Yes, sir. We can able to hear you, sir.
Great to see you. बताइए शेयर करें चालू करें
Ah, sir. Sir. Today we will be listening from you about drone swarm, sir.
Yes, that's right. So uh, I hope you can see my screen. Is it
Yes,
okay?
sir. Yes, it is.
Uh, so my screen is now visible, right?
Yes, sir. It is visible, sir.
Okay. Should I start or should I wait for some more time?
No, sir. So you can start, sir.
You start. So actually, there is one. I don't know how to handle this situation. When I make my screen full screen, I can't see others or I can't see anything like chat or something.
Sir, no
uh,
need to see any chart. At the end, we will take care about all the chart,
about
all
the
the questions,
questions. Okay,
all the
okay,
questions at the
okay,
end after your lecture delivery, sir.
okay. Got it. Let's start. So good evening again, and thank you, Dr. Nanda. uh, Actually, it is a wonderful experience that I'm again second time, and I speaking this time on my latest interest in the swarm intelligence field, that is the drone swarm. From last 5 6 years, I started taking interest in this, and very recently we have written few papers also, research papers also in this field. In this lecture, of this 1 hour lecture, I will try my best to cover as much as possible about the drone swarm. So please let me tell you that this lecture is an introduction to the drone swarm. The lecture is not going to make you the expert in the drone swarm, but definitely will be able to introduce this subject so that you can further explore it. What are the research areas, what are the research challenges, what is the state of the art. I will try to cover as much as possible. So first of all, I'll discuss in this lecture why the drone swarm is required, what is the drone swarm, what are the challenges in the drone swarm, and out of the challenges, one challenge is the position update in the drone swarm, for which I will tell you one just simple idea. And this idea will tell you that how further we can do the research in the field of drone swarm. And then another challenge, another research area or challenge in the drone swarm is the communication strategies in the drone swarm. So I will discuss few pros and cons of some communication strategies, and we'll check uh, um, whether they are going to help. And another is the application area, that where the drone swarm can be applied. Then what kind of drone swarms are available, what kind of drones are available. This I'm not going to cover this time because swarm intelligence is not necessarily the topic here. This was actually just to introduce the people who do not know the swarm intelligence. But since you are attending this workshop, and many speakers must have already told you about the swarm intelligence, so I will skip this part, and then I'll tell you that what is the present state of the art and the future of the drone swarm. Okay. So whenever I write DS, whenever I say DS, it is for the drone swarm. So first of all, before studying any topic or before studying anything, we need to understand that why it is important to study this particular topic. So drone swarm is important to study because unmanned air vehicles or the drones comes in a great variety: small drone, large drone, mid-sized drone, micro drone, macro drone. So for different kind of applications, different kind of drones are available, and therefore the a detailed study on the drone swarm is required, or the drones are required. Drone swarm is actually a collection of the drones. Formal definition I'll definitely give you, but we need to we need to study the core characteristics of the drone swarm to analyze and study and analyze the core characteristic of the drone swarm. Therefore, study of the drone swarm is important. We need to understand the functionality, problems, and importance of the drones. And most importantly, drone swarm is actually the fundamental future agenda. Fundamental future agenda means future transportation, future delivery, future HADR means human assistant and disaster relief. HADR is with respect to is with the drone swarm. I want to tell you that uh, future of the uh, HADR, particularly human assistant and disaster relief. Suppose there is a flood, then the drone swarm can better handle than the human beings or than the helicopter. So the drone swarm can better handle. So this is the future of the transportation, delivery, or HADR scenario, or of course the war, of course the defense. In my opinion, personal opinion, defense is the one most important application of the drone swarm. So why the swarm intelligence is important? Swarm intelligence, in my last lecture, yesterday's lecture, I already told you that the swarm intelligence is able to solve the problems which otherwise cannot be solved using mathematical algorithms. So swarm intelligence is of course important. Now you can immediately say that, okay, what are the industry applications? So the answer is, wherever you find any problem, and if you can model it as an optimization problem. Let me tell you, there's a very famous mathematician Euler who said that every problem, every industry problem can be modeled as an optimization problem. Of course, the complexity of the problem is different. So sometimes our limitations are there that we cannot model, but theoretically, any industry problem can be modeled as an optimization problem. So if you have an optimization problem, you can always solve that optimization problem using swarm intelligence. So the industry is actually looking for the swarm intelligence based method, because usually the industry problems are rarely dealt using the mathematical algorithm. You require the swarm intelligence or evolutionary algorithms. Okay. Particularly the swarm intelligence recently became in demand because of the drone and robot applications. Because of the drone and robot applications, swarm intelligence very recently in last 5 to 7 years became most important. Actually, became one of the most important technology. And the single reason is the drone swarm or the robot swarm. And this drone swarm or the robot swarm uh, is not only the for any industrial application or something like that. It is required for the medical applications also. For the drones, very famous medical application is that, in the emergency, you can delivery the blood from the blood bank. You can deliver from one place to another place, or any medical equipments or any medical help you can deliver with the help of drone. Another very recent technology is that, there are tiny robots, very tiny robots. So tiny robots can collaborate with each other and can be injectable robots. Actually, there are injectable robots are also available. So injectable robots can cure the cancer kind of diseases also. And this is possible because of the swarm intelligence, because these injectable small drones can collaborate with each other, and they can find out the actual cause root of the problem, and they can reach there. you know so in the minimum possible time, they can find the optimal solution. So optimal solution is the root cause of the disease. So injectable drones, injectable boats, we usually call them robots, we call them boats. So injectable boats, when go into the body of the human being, then they can collaborate with each other. So the swarm intelligence is everywhere. Actually, whenever you talk about the drones, you talk about the robots, swarm intelligence is required. Particularly for the drones, I tell you that increasing number of drones for defense is actually creating a big application area of the drone swarm in the field of the defense. And therefore, the drone swarm intelligence is important, drones are important, and therefore, of course, the drone swarm is important, particularly because of the defense. I already told you other areas of applications also. Okay. So why the drone swarm required? So I already told you that drone swarm is important for the military one, but their civilian applications are also attracting increased attention. in the recent times. Civilian applications are also there. Of course, I'm going to explain more civilian applications, but one just it came into my mind is the agriculture. In the agriculture, drones are helping a lot. Drones are helping a lot. You know, whenever pesticides are sprayed over the crop, if the human is there, then human eyes can analyze up with a limited speed. So whatever the area the human sprays the pesticide, but just imagine there is a drone and there is an onboard camera, and using the CVML algorithms, computer vision and machine learning algorithms, in the real time it is analyzing the leaf level, and whatever leaf is faulty, it is spraying only that particular leaf. So first of all, the um, application of the pesticides over the crop will be minimized, so it is safe for the health also, and of course you can save some money also of the pesticides. So overall, the application of the drones into the crop will definitely help over the human beings. Okay. This is the one, I tell you, that fundamental paper which I found which I studied in 2018 actually, and this paper was published in the Science Robotics in 2018. And in my opinion, you can say that this is one the fundamental research paper in the field of the drone swarm. This is a sample video. This is a video from that research paper which is into the supplementary material. It's a part of research paper. This video is a part of research paper. I request everyone to listen carefully. This is a very, very important video. Please listen carefully.
In this video, we will present fully autonomous multi-drone flights with a fleet of 30 quadcopters. They will fly in a confined area.
So this particular video is related to the 30 quadcopters. 30 quadcopters will fly together, and they will fly in optimized and autonomous way. Autonomous way. Important thing is the autonomous. Nobody is flying them. After takeoff, they are taking their decisions by their own. So please listen this documentary carefully.
Avoid collisions with each other and with virtual obstacles. This is a challenging task that has never been accomplished before due to its complexity.
We started our project many years ago by studying natural phenomena that somehow exhibit collective behavior. Animals, for instance, like birds or fish.
So this is, of course, based on the collective intelligence, collective behavior of birds or fish. So ultimately, the success of this project was the swarm intelligence. So please listen.
Show themselves by making decisions gathered from their neighbors, from local measurements, and other individual decisions. Drones are our intelligent flying agents. When they are airborne, they make decisions based on the bio-inspired models that we have created. The uniqueness of our drones lies in the fact that they communicate with each other in the air constantly.
So this is one very important aspect of the drone swarm, that all the drones are in the swarm are connected with each other, and they are always in the direct connected or indirectly connected, but they are connected.
Their flight is neither pre-programmed nor controlled by a central.
Very important. Their flight is not pre-programmed. Their flight is not pre-programmed. The onboard computer is taking the decision in real time. So whenever they take off, the GCS, ground control station, has no control over the drones. The drones are taking the decisions, right? Of course, they have the control. GCS has the control over the drones, but they are not interfering decision making. The drones itself are taking the decisions.
Ground station.
Our goal today is to present the principal building block of collective motion. Our drones will fly in a tight formation and remain within a bounded area. They will also avoid collisions with each other and with virtual obstacles. Similarly to natural systems, they will form coherent groups, split and reunite around obstacles, and turn collectively around goals. The challenge in this task is that the drones in the front will always have to inform the others at the back in time to avoid crowding at the walls. This is a very hard task even for people. Similar situations in large football stadiums or concerts can cause accidents or injuries.
The novelty of our model is that we take into account the finite acceleration of the drones in their local interactions, which means that we can scale the model up arbitrarily to high speeds or a high number of drones without loss of generality or stability.
We always test our algorithms in a realistic simulation framework before flight and tune the parameters for best performance. We optimize our solutions with an evolutionary.
So they optimize this solution, the flight, the speed, the coordination. So everything is optimized using the swarm and evolutionary algorithm. Particularly, they have applied the CMA-ES algorithm, covariant matrix analysis evolutionary strategy, for optimizing the solution.
Algorithm. Our aim is to maximize the speed and the coherence of the flock while minimizing.
So their objective is actually it's a multi-objective optimization problem. We also have solved this problem using the NSGA2, and we found, in fact, slightly better results than their results. So the objective is to maximize the speed while creating the flock of the drones intact, and when the speed will increase, there is a chance that they can collide with each other. To minimize the collision, to maximize the speed, to maximize the collaboration, and to minimize the time in reaching the uh, target area, 7 actually objectives are there. Then they further reduce to these 2 objectives and then solved using the CMA-ES algorithm. We also did it using the PCA, principal component analysis. We reduced the number of objectives and solved using the 2 objectives using NSGA2.
Oscillations and collisions.
And this is the real video. Please see, this is a real video, not a simulation. It's a complete autonomous flight.
Take off and switch from individual to collective behavior. They quickly find a consensus on the direction they will be heading. After a short initial phase of hesitation, they find consensus and fly away smoothly. The quality of our model can be assessed by how efficiently the drones are able to make collective decisions. In a highly optimized system, collective motion patterns emerge naturally and remain stable throughout the flight.
And to visualize the flight, we created a program in which the color is determined by the direction of the drone itself. You can see that if I move around the drone with different directions, it will change its color.
This is a real video, and in the night flying, the drones can take the guidance from the other drones by just observing the lights of one drone to another drone. It's a complete autonomous flight. Nobody is controlling them or guiding them. Okay, now let's start with the formal definition of the drone swarm. What is the formal definition of the drone swarm? Drone swarm means it is okay. Let me, before I define this drone swarm formally, I want to tell you that what is not the drone swarm. What is not the drone swarm, so that you can understand what is actually the drone swarm. You must have observed the after the 26th January, in the what is that called, after the Republic Day ceremony, there is a show of the drones beating retreat ceremony. During the beating retreat ceremony, the drone show is there. So 2000, 3000 drones are flying and they are making different shapes. They are writing Bharat, India, or different shapes they are making, the drones. So if you see there, the 2000 drones are flying over there and they are making different shapes. Actually, during this process, it is a predetermined flight. It is a pre-planned flight. So this is not a drone swarm. I want to tell you that when the 2000 drones are flying there and they are making different shapes, it is not a drone swarm, because it is not an autonomous system. Whatever they are doing, whatever their positions are there, XYZ component is there, XYZ position. So for every movement, XYZ T means time. At particular time, they have to be at this XYZ, and then every drone has their own location and the time, that at particular time I have to reach at this position and I will follow this path. They will follow that path, and of course we will see that particular shape there. So it is all a predetermined flight, pre-planned flight. It is not an autonomous flight, and therefore that is not the drone swarm. This is very important. And they have no interaction in between. That one drone is not interacting with another drone. Actually, what is there, this is an interacting. What is actually the drone swarm is that the drone swarm must be interacting with each other, must be an autonomous set. The drones must be flying autonomously. During the video, I was every time stressing that the drones are autonomous. That flight is autonomous. Autonomous means nobody is controlling them. Nothing is pre-planned. Nothing is pre-planned. Whatever they are doing, they are making the decision on board and flying. So first of all, and how they can fly, because of the interaction. They interact with each other. Like in the last lecture, I was discussing that honeybees, they do the dance, and they inform others that from where I am coming. So this interaction is required. Similarly here, the drones are interacting with another using the local network, and the drones are flight is autonomous. And another word is the group of drones. It is a group. If you ask me that 2 or 3 drones, you can expect some intelligence? No. In the swarm intelligence, some minimum number of drones are required, minimum number of swarm members are required. But what is this minimum number is actually depends upon the problem complexity. If you have a different high complexity problem, then of course you may require more members of the swarm. If less can work. But usually 10 or so, 10 or more can project can produce one swarm intelligence. So group of drones is required, not a single drone can perform the swarm intelligence. And the another word is it is assigned. It is assigned to perform a or some task. It is assigned to perform a or some task. It is not just for the fun flight. It is not a fun flight. It is assigned to perform some task. Some task they should be able to do. For example, if they are the defense drones, then they may go to some area, can drop the bomb, can do the reiki, whatever kind of purpose they are designed, they should be able to do some task. In drone swarm, in general we expect that every drone has the same configuration. All the drones are with the same configuration, and any drone can perform the task which anybody else can do. And this is actually required because just imagine that you sent 10 drones for some mission, and at the mission, when they reach at the mission, one drone is killed or one drone got some malfunction, crashed. Now you have only the 9 drones. Then the 9 drones should be able to redefine the task assignment, task allocation, so that the task can be completed by these remaining 9 drones. And this is possible only when all drones are of the same configuration. Just imagine that the one drone is there who has the camera. and other drones are taking the camera feed from this drone. This drone is taking the camera feed, and it is broadcasting the camera feed to other drones, and other drones accordingly moving. Now just imagine if this drone is crashed, then how about other drones? They will not be able to do any task, and therefore it is required that every drone should have the same configuration. This is called the homogeneous swarm. We call it homogeneous swarm, or we also call this as a single layer drone swarm. When I will explain the classification of the drone swarm, I will explain that also, but right now let me tell you, it is called a single layer drone swarm. Okay. Objective of the drone swarm is to develop an autonomous system, autonomous system which consists of the GCS also, which consists of the drones also, software, flight controller, everything is there. It's a complete system, and this system must be a completely autonomous, and this system consists of a group of drones, typically 30 or more. Why I wrote it 30 or more here? Because you can expect better swarm intelligence when you have the uh, swarm of drones where with more than 30 drones, then you can expect better swarm intelligence. Okay. Next thing is the connection among them. Connections among them. Connections among them means how they are connected with each other, how the drone swarm are connected with each other. I call it the communication strategies. What communication strategy they are using, I will discuss more on this in my coming slides. Then next thing is the ability to perform a well-defined task. They should have the ability. If they are the defense drones, then they should be able to do that. If they are the agriculture drone, then they should be able to do that, and so on. And let me tell you with one example, then at this stage there may be an immediate question that why we require the swarm of drones. Why not single drone? Let me tell you one very, very simple idea. Suppose this is the wall. This is one wall of a room. This is one wall of a room. And I tell you that one person takes 10 days. One person takes 10 days to make this wall. Then 10 persons will make definitely 1 day to make this wall. What I said? One person can make this wall in 10 days. Then 10 persons can make this wall in 1 day. But if these 10 persons usage some swarm intelligence based algorithm when making this wall, then definitely time taken to make this wall will be less than 1 day. If they are independently working, then definitely they will take 10 days. But if they will collaborate with each other, then there is a special kind of intelligence will emerge, that is the swarm intelligence will emerge, and it will make their time less than 1 day. Means that these 10 people will be computationally efficient. In that case, they will be computationally efficient in making the wall. So if one drone can do the task in 10 hours, then 10 drones can do the task in less than 1 hour. And in the case of avalanche, flood, fire broke, uh, you know fire broke, earthquake, in these kind of disaster situations, time is important. One drone can do the task, but time is important. You can save some more people if you can do the same thing in less time, and at that time the swarm intelligence is important. You need the group of drones who can collaborate with each other, who are communicating with each other, and can perform the task in minimum possible time, whether it is wars like situation, agriculture, or the delivery of some medical emergency. In case of medical emergency, in case of the disaster situation, time is important, and this is possible only when you have a drone swarm, and drone swarm with the swarm intelligence based algorithm. And therefore now I hope by this time you can understand well that the drone swarm is the fundamental future agenda of the technology. Fundamental future agenda of the technology, let me tell you. this is the future agenda of the technology. Of course, right now we are not that much equipped with the swarm of drones. With the drones, of course, we are very comfortable at this moment. We have very robust drones are available at this moment. They can travel 500 kilometers, 200 kilometers. We have the drones which can perform, which can travel for 10 hours, non-stop 10 hours. We have the drones or unmanned vehicles. But at this stage is still the collaboration is missing, the algorithms are missing, the network is missing, so that the 100 such kind of drones are working together and they can perform the task. Okay, the swarm members should be able to communicate and collaborate, preferably without central control. Without central control means without GCS. The swarm should be an independent and autonomous system which can find out the target in complex landscapes. Okay, classification of the drone swarm. I already told you that our ultimate target is the fully autonomous drone swarm. But sometime actually for the robustness or for the safety purpose, sometime we control the swarm from the GCS. In this case, we call it partly or semi-autonomous system. What does it mean? Let me tell you. One example I tell you. There may be a situation of the war, right? You are sending 10 drones to the war area. In the war area, 10 drones are searching their enemies and dropping the bomb, searching that particular location and dropping the bomb. Okay. Another case may be that they are searching the enemy, and then based on this feed, this feed is then broadcasted to the GCS, and at the GCS the operator is triggering the bomb, whether I really want the one bomb to be launched here at this moment or not. Sometimes even if you see the enemy, but there is one enemy or one soldier, enemy troops, one soldier is there, you don't want to waste your bomb. You want 10 soldiers to die with one drone, with one bomb. In that case, the operator can take the decision. So in that case, man in loop is there, and therefore we call it semi-autonomous swarms. Another classification is based on the communication. It is called single layered is actually ultimate objective. Multi-layered is actually what is currently quite good. But single layered is still there, but it is not as robust as we expect or we require. Multi-layered means you have, suppose, uh, these three drones and these three drones, and these three drones are communicating with this one drone like this, and these three drones are communicating, and these two drones are communicating with this one drone, and this one drone is communicating with the GCS. So ultimately GCS is connected with this drone only, and this drone is taking the feed from these two drones, and these two drones are taking feed from these three drones, right? So ultimately, these six drones are at the ground, which are actually taking the input, and these three drones are actually just communicating the drones or processor drones. They are processing the information. Of course, it is an autonomous system, not a problem. But what is the problem here? That this system is not robust system. Just imagine if this drone is crashed, then these two drones will lose the connection. This is the drone who is the connection between these two drones. Now imagine if this one drone is crashed, then these three drones will lose the connection with these remaining five drones. And therefore this multi-layered drone swarm system is not preferred. But this kind of system is very cost effective, because these six drones who are actually taking the inputs, they may have only the camera, and they may transmit the images to this drone, and this drone may transmit do the analysis, and whatever is the final analysis, it can transmit to this. So the processing time over these drones are reduced. Each drone it is reduced, and you may not require to put the computer over each drone. Over each drone, you require the computer only over these two drones, and therefore they are very cost effective, relatively fast also, because one drone is require less computation time, requires less computational time. But the system is not robust. This is important thing, that the system is not a robust system. It is a very fragile system. Now just imagine another situation where each drone is connected, each drone is independent and actually connected via one or another, like it is, they are connected like this, and they are sorry, they are connected directly also. Let me make it here. I'll take only four drones. They are connected directly. All the drones are connected directly. Now, even if this drone is crashed, then these three drones are already connected. So there is no problem. Three drones will do the task, and therefore we require the single layer drone swarm system. But in this case, since each drone is getting remaining three inputs, so the processing time over a single drone increases, and therefore the overall speed will be reduced. When you actually apply the drone swarm, overall speed will be reduced. Also, the cost will also increase, because our single drone, you have to put all the things, all the hardware you have to put over the single drone. Okay, the update in the drone swarm, actually what happens, the new position of the drone swarm, it is based on some correction that, you know, yesterday I was telling you that all the optimization algorithm, whether it is deterministic or probabilistic, new position equal to old position plus lambda d. This is the direction. Suppose this is your direction and this is your step size. So it is based on this formula. Now, how to calculate this direction, how to calculate this direction, and how to calculate this step size differs algorithm to algorithm. For PSO it may be different, for ABC it may be different, for ant colony optimization it may be different, for genetic algorithm it may be different. But ultimately what you are doing, what you are actually calculating, you are calculating the distance and the direction, the step size and the direction. Overall, let me call this as h. This is your h. Similarly, in the drone case also, we need to calculate this h. And one very simple idea of this is this formula, that whatever is the best solution or best direction you have available, just follow that direction. And of course, with some weight, with some confidence level. So this T is that confidence level. This is one very simple idea for the position update equation in the drone swarm. Okay. I just want to share some research challenges in case of the drone swarm. And these research challenges are actually the very important. One most important challenge is the topology used for communication among drones. I just explained you the single layered and multi-layered, how they are connected. Here I was telling you that everybody is connected with everybody. So of course I told you that this single drone will get three feeds and the processing time will be less. Oh, sorry, will be high, because you have to process so many information on this single drone. Now, is it possible that you can minimize, you can reduce this processing time while keeping your swarm robust? This all can be done with the help of communication topologies. So communication design of the communication topology is an area of research, is an important area of research, so that you can increase the overall efficiency of the swarm, speed of the swarm, and the robustness also, while maintaining the robustness. Okay. Another thing is that for the given task, what is the minimum number of drones required to implement that proposed strategy? Actually, what happens, if you are given, just imagine that you are given 1 by 1 kilometer area, and you are told that there are 5 people who are stuck in flood or stuck in avalanche, and in this 1 by 1 kilometer area you have to search, those 5 people in the 1 by 1 kilometer area. Then you have to decide what is the minimum number of drones I require for this 1 by 1 kilometer area to search. And you are also given the time that, okay, in 10 minutes you need to search, in just 10 minutes you need to search. So for 10 minutes in 1 by 1 kilometer area, search how many drones are required. This calculation is very, very critical, very, very much required, because more the number of drones you will send, more the money you will require, more the investment you require, the cost will increase. And of course, more the drones you will send, the less the speed, because every drone has to process the information received from other members. So your speed will reduce, your cost will increase unnecessary if you are sending the drones for that particular operation. So you should know that for uh, executing that particular task in 10 minutes, how many minimum number of drones are required. Very important research area. Another research area is that what is the maximum and minimum distance between any two drones of the swarm. If the drone swarm is flying, then what is this minimum and maximum? This is the distance between any two drones. Minimum, the closest drone should come how close? If this distance is very, very close, then they are moving at very fast speed. There is a chance that they can collide. If they are very far from each other, then this last drone and this last drone, means the diameter of the swarm, they may lose the connection. They may not have the connection. If the distance is very high, then in the local network they may lose the connection. So you cannot increase the distance at your will. You cannot minimize this distance too much, because maximum and minimum both have their own drawbacks. And therefore, what is the optimal size for the maximum and minimum distance between any two drones? Very, very important research. Okay. Another is the self-healing. What if you are given, there's an algorithmic strategy you need to plan. You sent 10 drones to do a task, to execute one particular operation. You sent 10 drones, but the enemy killed 2 drones. Now you have only 8 drones. Now how they will redefine, self-healing means how they will redefine the algorithm of executing the task, so that the work can be done by the remaining drones, only 8 drones. Of course, the time will increase, but that time should also increase as less as possible. So I told you that overall self-healing is, again, means it is an algorithm design onboard strategy design. Last part is the GPS denied environment. Actually, what happens? Drones take the feed from the GPS, from the satellite. They decide their positions, X, Y, Z. It is decided by the GPS coordinates, right? So they take the feed from the satellite. What if satellite signals are lost? What if satellite signals are lost, then GPS lost? And if the GPS lost, then drone will forget that where I am, my friend is there or not. Nobody knows what is their own position. What is their position? It is like, in the sea, you forget the direction, that where I am, what is my location, in which direction I am moving. You use compass for that purpose, but compass will also not help, because compass can show you only the direction, will not show you that what is my current position and how far I am from that particular location, where I have to reach, and where are my other friends in the swarm, where are other birds in the swarm. They can collide with each other if they do not know the XYZ. In this situation, how to handle this this phenomena, that if the XYZ or the location parameters are lost, then how they can handle. This is another research area. So these are the 5 very important research challenges in the field of drone swarm. You can do a PhD over a single topic. In fact, out of these 5, you can do the full PhD out of a single. Okay. Communication strategies, there are many different kind of communication strategies are possible, but just for example, I tell you, I made it by hand actually. uh, just uh, I was making them, and I thought that I will draw it by the computer, but then I lost my interest in making this, so I put just the photograph of this. You see here the 4 drones are there, and then this is another. These 4 drones are connected with each other. Now you see these 4 drones are connected, these 4 drones are connected, so you see that these 2 drones are common in both. So whatever is the information it has, this drone will also have, because this drone has these 4 drones are connected with each other. These 4 drones are connected with each other. So based on this information, whatever the information it has, it can reach here. It is called local neighborhood. In this case, what happens if this, even if this single drone crashed, but this another drone is there who can communicate, who can keep on sharing the information. So if the 2 drones are there in common, they can share the information with each other. But of course, more the common the drones, less the speed, right? More the more the calculation. Okay. So what can happen? You can keep a single drone common. You can keep single drone common, that these 3 drones are not directly connected, but they are connected via this, like a multi-layer drone, and they are connected with this, they are connected like this. But this is again not a robust situation, because if this drone is killed or crashed, then this entire part will be lost. And therefore, what else can be done? You can keep 2 drones as a node drone. As a node drone, you can keep 2 drones, so all the other drones are connected with these 2 drones both. And similarly, these 2 drones are connected again. These 2 drones are connected again, and these 2 drones are connected again. And uh, in this case, even if this one drone is killed, it will be communicated. Okay. So now I just quickly tell you, then I'll take the question answers also. Application areas of the drone swarm: security, survey, monitoring, surveillance. Of course, it can be done by using the drone swarm. There, the day is not far when in your housing society. If you are in a housing society, uh, your housing society, there may be a drone flying over your housing society with a camera, and you don't require so many CCTV cameras all over the areas. A single drone can monitor the entire housing society. So surveillance, monitoring, security, definitely. Disaster management, I already explained a lot, that if you have avalanche, flood, earthquake, fire block, in this case, the time is very important, and therefore the drone swarms are very important. Search and rescue, classification of UAVs. Actually, there are many types of UAVs available. I tell you, uh, tricopter, quadcopter, hexacopter, octo. Let me just show you some uh, figures you can understand. These are the fixed wings. They are the fixed wing. They do not have the rotors. They have the fixed wing, so they require the runway for the takeoff. So there is a limitation, but they have a high speed. Speed is very high of these drones, but definitely these drones are not very much suitable for the swarming, because with the high speed, the data communication should also be with that particular speed, and therefore sometime communication becomes a problem for the fixed wings. Then there is another solution, the hybrid. These hybrid take off and land vertically, because they have the rotors, and they have the wings also for the forward flying. For the vertical flying, they have the rotors, and for the forward flying, they have the wings, so they can maintain the speed also without the use of the runway. Okay. It's a single rotor drone. Here is the hexacopter, 6 rotors. They are usually suitable for the drone swarm. Quadcopter, 4. Okay, I'll skip the swarm intelligence application, introduction of the swarm intelligence. I just want to mention that what is the future of the drone swarm. You know, I tell you that you must study ant colony optimization algorithm, particle swarm optimization algorithm, few other algorithms, and try to implement these algorithms to the drone swarm, because the drone swarm market is increasing. It is CAGR of drone swarm is 37.49%. Just imagine, this is not a small increase rate. This is a very good rate. As far as the industry uh, application is considered, it's a very good growth rate. So the drone swarm future is very bright, particularly in the field of medical, military, agriculture, security and surveillance, and of course the delivery. Another application, just quickly I tell you, the time is limited, but just quickly I tell you that, you know, there will be a situation when the people will have autonomous cars, self-driving cars, and when the self-driving cars will be there, then they require communication among them also, because suppose one car face some problem, or some kind of uh, traffic congestion, or some kind of sharp turn, or any kind of problem one car faced, then it can in real time communicate to other cars that, okay, if you are moving to this, there is a there is a uh, there is a stone, or there is some hurdle on this particular path, so slow down the speed. Similarly, the same situation will occur when the drone taxis will be there. If the drone taxis will be there in the market, then the drone taxis should be able to communicate with each other, because if they are the autonomous vehicles, self-driving vehicles, then they must be able to communicate with each other to minimize the traffic at particular location. State of the art, I tell you that there are many key players in the swarm intelligence market. For example, DoBots is a company in Netherlands, Hydromia, Sentient Robotics, Unanimous AI, Action AI, Swarm Technology, SSI, Vertigo, NSwarm, Power Blocks. These are some leading companies in the field of the drone swarm. I tell you that the India and the South Asia is slightly lagging behind in this technology, and therefore Government of India is also promoting the drone industry, drone technology in India like anything. A lot of fundings the Government of India right now giving to the startups who are investing in the drones. And of course, the drone swarm, for the swarm, the hardware is the same. The drone is there, right? So for the drone swarming, the algorithms are required. Communication algorithms are required. Communication topology is required. I told you those 5 points that is required. Means the academicians are required, researchers are required. Funding is the one thing, of course, but majorly the research is required for the drone swarm. Of course, for the drones, the factories are required, funding is required, investment is required, but for the drone swarm, research is required, and that the algorithm development is required. So China, of course, is doing good in this APEC. South Korea is also doing good. Okay, that's all from my side. I'm okay now to take the questions. I'm okay to take the questions if you have. Professor Nanda, I think people will write in the chat box, right?
Yes, sir. They will be writing the question in the chat box.
Okay. If you have any question, please tell me. Thank you so much, Dr. Krishna Kumar. Thank you. Thank you so much, Dr. Richa Rani and Tina Raikwar. Okay. I know this is actually an introduction to the drone swarm, and definitely you can further explore and can see my research paper also on the drone swarm. So can we use this drone swarm intelligence in inverse optimization problem? Inverse in inverse optimization or inverse optimization for the drone swarm is an application. I think your question is not proper. You want to say that inverse optimization drone swarm is an application, right? So itself an application. How you can do the apply the application to another application? Yes, you are right, Ayushi. Yes, you are right, Ayushi. It is an application, not a method. Thank you, Manish Kumar ji. Okay. So in that case, if no question, then we can finish that session. I see that questions are not there.
Yes, sir. And further, if they have any questions, so they can also mail you or mail us, so it can be followed.
Yes, definitely. My mail ID is very simple. Just Google my name. You will find as such jcbansal@sau.ac.in. You will find my email ID, and I'll be happy to answer your queries on email also. In fact, it's my pleasure to discuss on these kind of latest technologies. It's my very recent interest. I have written 3 papers till now in the field of drone swarm, but researching and writing paper is a time-taking process.
Yes, sir.
Okay.
Totally agree with you, sir. But, sir, it is our honor also to have you here, and this is very trending topic nowadays. Drones are
Yeah.
very important, and then unmanned vehicle, and then above than that, the
Yes,
swarms of this. So this is a very live problem nowadays. So I
that's
think
right.
hope all the participant will get benefited from it, and we will be seeing many more lectures from you, sir, in the upcoming.
Thank you. It's my pleasure. It's my pleasure, and really, you are doing good. Kudos to you, Professor Ila and Dr. Nanda. Thank you so much.
Thank you, sir. Thank you so much. Namaste.
Thank you. Namaskar. Namaskar.